Good morning, sir. Myself, C. Govindarajulu, and I am studying in your college in second BTech, first semester. And today, my topic is minimum spanning tree and its algorithm with an example. First of all, we have discussed about what is minimum spanning tree. The minimum spanning tree is a subset of edges in a weight graph, and it connects all vertices together without any cycles and with the minimum possible total edges weight. And minimum spanning tree is crucial in network designing, clustering, and various optimization problems. What is a spanning tree? Spanning tree includes vertices and edges. Importance of minimum spanning tree. The main importance of this spanning tree is minimizing the cost of connecting different points in a networking. It is in a design efficient network layouts such as telecommunications and computer networks. These are used in software development, and these are understanding can be led significant savings in both time and resources various applications. These are plays very vital role in the network designing and some other software works. And properties of these spanning trees. Minimum spanning tree is a graph is unique is all edges, weights and distinct. If any edge is included in MST, no cycles is formed, preserving the tree structure. Every connected graph has at least one minimum spanning tree. Here we can see the example of minimum spanning tree. This is a minimum spanning tree. Here we see there are 7 vertices and 6 edges. Here the edges are not connected to circle, and these edges cannot form a circle and closed loop. These type of tree are said to be a minimum spanning tree. Then here we can find the weight of a minimum spanning tree. Then we find the 10, 25, 22, 12, 16, 14. Then we get the weight of this minimum spanning tree. Then common algorithm for finding the MST. This finding the we can have two algorithms that are Prim's and Krunkel's algorithm are the most commonly used method for finding an MST. Both algorithms use different approaches to achieve the same goal of minimizing edges weight. Their application may vary based on the graph structure and edge distribution. Prim's algorithm overview. We see the Prim's algorithm. Prim's algorithm starts with a single vertex and expands the MST on one edge at the time. It selects the minimum weight edge that connects a vertex MST to vertex outside it. The algorithm continues until all vertices included in the MST. First of all, we can take this any. First we visit first node, then we visit next node, which has the minimum weight. That path we can select to travel that edge. Steps to solve the Prim's algorithm. First of all, we can begin with the arbitrary starting vertex and mark it as a part of MST and select the minimum weight edge connecting the MST to vertex outside the MST. Repeat the process until all the vertices are including in MST. Example of Prim's algorithm. Here we see the example of Prim's algorithm. This is the example for diagram, systematic diagram, and here starting vertex is 0 and select the minimum edge leading to 1. Why we have select the one vertex? Because here 0 to 1 has weight has 4 and here 0 to 7 has weight 8. That's why here weight 4 is less than 8. That's why we can select traveling through the vertex 0 to 1. Here continue adding edges until all vertices including resulting in the complete MST. Here we visiting every node but do not form a closed loop. Krunkel's algorithm overview. Krunkel's algorithm sorting all edges is not decreasing of their weights. It adds a MST one by one, ensuring no cycles are formed. As The process continues until the MST includes all vertices. Step 2, Kunkel's algorithm. Sort all edges in graph by from smallest to largest. Iterate through the sorted edges and add each edge to MST. It does not form a cycle. Stop when the MST continue V minus 1 edge, where V is the number of vertices. Here, this is one logic that we have find the number of edges that are formed with. You have number of edges, if they have considered number of vertices is 7, as it is this edges are formed 6. Then comparison between these two algorithms. Prim's algorithm is generally more efficient for dense graphs where the number of edges is high. Kruskal's algorithm is preferred for spare graph with fewer edges. Both algorithms have their strength depending on their graphical characteristics. Applications of minimum spanning trees. MSTs are widely used in networking to design efficiently communication networks. Yes, these connecting the one region to another region, we can follow the signals. These minimum spanning trees are used. Then it clustering analysis, MST helping grouping similar data points. They are also used in various optimization programs across different fields such as transportation and urban planning. These are very important in human life. These minimum spanning trees are play a vital role to solve any problem that I have to face in a society. Then real world example, they can tell about this network design. Consider a telecommunication company that needs to connect various towers efficiently. MST can reduce the cost by minimizing the total length, cables and required for connectivities. By applying MST algorithm, the company can optimize their network layout efficiently. Here we see the diagram, there each other connected to one each other. This the signals are connected to then here network design. Conclusion: minimum spanning trees are essential in various fields requiring efficient connectivity. Prim's and Kruskal's algorithm provided robust methods for finding MSTs. Mastering this concept can lead to innovative solutions in network designs and optimization. Thank you, sir.